morning. Welcome to another episode of Xa Talk Show. We are going to do Advent of Code 2025, Day 3, Part 2 with Wolfram Language, the fantastic Wolfram Language, the most magnificent, a magnitude higher level than all other programming languages, including Python, Lisp, Haskell, Rust, F#, Julia. One line of Wolfram language is 10 or 100 lines of Python. Okay, so Wolfram language, you can download it here. Just search for xali.info, Wolfram language tutorial. You'll find it. Okay, so let's begin. So Advent of Code. So part 2. Okay. Now last check. Video check. Yes. Audio check. Yes. If you are here, say hi. If you are not here, play at 1.5 speed or 2 times speed. Okay, that would be optimal. So Advent of Code. So let's see. Day 2. Continue to part 2. So the problem was Advent of Code Day 3 was that you are given a list of numbers. Okay, such as like that. A list of numbers. For each number, you have to pick 2 digits. Okay, it says here. Now the Advent of Code is pretty lousy. I talked about this before. Watch my previous videos a few days ago. For example, their website is hard-coded. You see, you cannot. So if you enlarge the font, you also have to enlarge the window. Also, you see, they use the dark theme background. Very annoying, unreadable, illegible. You know, these people, they don't know these industrial coders. They think this is cool. This looks cool. But one way to tell, now you might be a dark theme fan, but one way to tell it is not good for your eyes is that when you do live stream, live stream video, you can see as you watch my screen, this dark theme is just not good. If it's white background, it's much more easier to read. Okay, this is one way to tell why dark theme is actually not good for your eyes. So the Advent Code, they hard coded their website layout and they use dark theme. Okay, they got issues. Anyway, let's continue. So the problem Day 3 is that you are given a list of numbers. For each number, you want to pick 2 digits. Okay, pick 2 digits. Then you combine the 2 digits into a number. You want to find the maximum. Okay, so for example, this A1, A19, 11112111. The result would be 89. Okay, then for the 2 digits you picked for each number, you add them up, then that should be your answer for the first problem, 357 for this example input. Okay, we solved that yesterday. Today, let's go to part 2. Okay, part 2. Now let's read. The escalator doesn't move. The elf explained that it probably needs more jolt to become static friction of something hit something. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. Okay, instead of picking 2 digits, now you pick 12 digits. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's joltage output instead of 2. A bunch of fairy tale mumbo jumbo. So what it is saying is that given a number, you want to pick 12 digits. And in order from left to right, you can pick 12 of them. Okay, then you combine these 12 digits you picked in order from left to right. You cannot randomly mix them. Okay, then you want to pick digits such that they create the maximum number. Okay, now so blah blah blah. So let's copy. So we can begin to code actually. So let's just copy Advent of Code previous. We did this yesterday. I still have a cold, so I got cough. Very painful. Okay. Okay, let's start to code. Okay, let's begin a pre-block of Wolfram language code, paste it and pop it out. Here is our previous code. It's so trivial. Now we just pick 12 digits instead of 2. Okay, hold on a second. Let me go cough. Okay, I'm back. Dearly beloved. Anyone here comment? Okay. So now you pick 12 digits. Let's see. So previously we are picking 2 digits. Digit 1 we actually hard coded. So now the job is to pick 12 digits. So let's do like before. Let's pick let's see, 12 digits. So let's say that's a number. You turn into a list. Okay, integer digits list. Okay, that will give you a list of digits. Then let's see. Okay, hold on a second. Okay, you return a list of digits. Then you pick one. You need to pick 12 of them. How large are these digits? Let's see. 15 characters. So there are 15 digits. Now let's look at my advent of code personal input to see how many digits. Okay, so there's plenty. So let's try 100 characters. Okay, there are 100 of them. Okay, close. Now we'll go back. So now you need to pick 12, but how many are there? 15 here. Okay, so you need to pick 12. So you turn it into a list. You pick the okay, you must pick. So are there any 0? Let's see. We need to are there any 0? There is no 0. Very interesting. You see, tricky. This advent of code, tricky elves. You know, if there's 0, then then the problem would be more difficult. Okay, but there's no 0. You see this personal input, there's no 0 in it, but it didn't say, it doesn't tell you, you see. So it needs, but how do I know? So maybe someone else, their personal input would contain 0, but I doubt it. Again, like I said, advent of code is quite lousy because the spec does not say the number does not contain 0. Does it actually say search for 0 or search for a digit and see search? You see, it doesn't say, it doesn't mention there is no 0 in these digits. It doesn't say. So that means, according to the spec, you must assume your input might be 0, might have a 0, in one of these, digit 0 in them. However, if there's 0, your algorithm will be more complicated. Because when there is 0, you need to deal with well, anyway, it's gonna be more complicated. Okay, but it's likely it's not just gonna not contain 0. So if you do not consider that it contains 0, your algorithm will be much simpler. But however, it technically it would be incorrect. You know, by my personal input, I might get the right answer, but some other people might get the wrong answer using my algorithm because their input has 0 in them. So this advanced code is not very good. If, in that case, it's not fair. Anyway, so let's just assume there's no 0. Okay. So so you got a bunch of digits, a list of digits. You pick 12 of them. So that means the choices must be, you must leave 11 of them behind. So you can only pick the front something because you need to have 11 digits behind. Okay. So we can actually just start to modify our code. Let's see, you see this drop 1, y1, because previously we picked 2 digits. So once we pick, we have to drop the last one to leave room. So now, so 1 because 2 minus 1, okay? Now in this case, it will be 11 because 12 minus 1. So that will be 11, negative, drop the last 11 digits, okay? But, okay, you need to modify this algorithm because this algorithm hard code 2 digits. Now you need, okay. So should we directly work on the algorithm, or should we go by like first do an example step by step? Let's do an example step by step, okay? Comments, if you are here watching comments, okay? So you need some kind of slot result list. You need some kind of result list of 12 items, like 1 to 12, something like let's say, okay, you need like a slot, a list of 12 items. That's your result. Okay, so enter. So wait, where's the equal sign? Now in the beginning, actually it's gonna be empty. Okay, watching from Sweden, fantastic, Magnus Olofsson. Now seen Wolfram Language before, never seen Wolfram Language before. Oh, okay. Okay, let me focus in it. I need to do a good job. Okay, so result is a empty list. We're just gonna push it. Okay, so so first of all, you pick one. You need to leave room. Okay, so let's start to like digit list equals to that. Okay, then result list, then you pick one. So you do this drop digit list and pick the maximum. That's a digit 1. You push it to, you append append. Okay, so you append actually append 2. So when you have a variable, you append 2. Append 2 is like push, okay, to the end, like push in Python or JavaScript. Append element to the value of x, reset x to the result. Yeah, so you append to x result by this thing. Okay, and you need to repeat this 12 times. Let's see, and each time the number dropped would be wait, hold on a second. So you drop the right hand side, then you pick a max. Wait, so you need to okay, you need to you pick a max, then you need to know its position. Okay, like here, you need to know the position. Okay. Let's do it. Let's hard code this for now. Okay. So x digit 1 equals to, let's just hard code this for now. Okay. So it's easier to understand. Then you append to the result. So actually, let's just say x result equals to append x result digit 1. Okay. Then you do this again. Let's just repeat this. Let's see if that works. Digit 2. Let's see. So once you drop, you pick a digit, then you must know the position. Okay, this you do this only one shot, one time. Then you need to know the position. So so digit 1 position. So let's okay, position is like index. So digit 1 position equals to the first one. Yes, the first one among them. So if there is more than one, let's say there's 8. This is not a good example. So let's pick some good example. Let's say that. Okay, so if the you see that's the result. So if so there are several 8. You pick one. So the position, you pick the first one, okay? That would be the leftmost, right? You want the leftmost. Then you need to know the position. Then we set it here. Then you pick, yeah, so then you pick the digit 2 would be equals to, let's see. Now this time you drop in front of it up to the digit position. Okay, then you pick the max. So that would be digit 2. Okay. Then so let's forget about the result list yet. Okay. So now digit 3 would be okay. Now digit 3 then now you need the digit 2 position. Oh God. So let's not do this yet. Okay. Yeah, let's not. So digit 1, then digit 1 position, and digit 2, then digit 2 position. Okay, looks like that. Check, let's double check. Digit 1 position, digit 2 position. Then let's do digit 3, is that right? So digit 3, okay, looks like that's the pattern. Now the exception is just the digit 1. The first one is -11. Okay. Wait, do we need the max. We need to apply the max here. So max at just means is a shortcut for the square bracket. Okay. So digit 1, then digit 1 position, digit 2 position, digit 3 position. We can just we can manually repeat this until digit 12, but that's a pattern. Okay, so let's write a loop to do this. Now, Wolfram language is a functional programming language, predominantly, pretty much like Lisp. Okay, so we're gonna code this loop in a functional way. Let's see, how do we do this? Okay, let's color this. Okay, save it, close it, reopen, and recolor. Okay, digit one position. So they are kind of nested, digit one position. The whole solution is gonna be one single line, very short, 200 characters, something like that. So instead of using drop, we can use take. Drop, take from digit 1 position, doesn't matter. Okay. So let me think. Recursively, yes, that is the right way. Either we're gonna use fold, also known as reduce, or we're gonna use the nest function. Okay, I shouldn't digress, but so let me, well, this is my tutorial. Okay, so tutorial, you go to list section, introduction to list. Then there is list operations. Then you have lots of recursion. So map, iteration, combinators, transpose, padding, map function to list, scan, fold, loop, recursion. So there's lots of recursion related. Let's look at recursion. Okay, so you can have nest while, which basically does recursion for any function. Any function, that function is not recursive. It does not call itself. However, you can call nest. This allows any function to recursively call itself. Okay, then you have nest while, which lets you specify a condition. When should it stop the nesting? While the nest is just a number of times to stop. Then you have fixed point, which is it'll just continue to nest until the result remains the same. So the result then feed back to the function a new result. If the new result and the last result is the same, it stops. That's fixed point. Then you have recursion involving two arguments. That's fold, also known as reduce. This is the most generic loop construct in a functional style. Okay, so I think we're gonna use either fold or the nest. But let's get back to this. So each loop you can so after you done each one of the selection, you can do the append to the result list. Okay, so you can so you need to do this 12 times. Do it 12 times. So you need to do this 12 times. That's the thing. That's a key. So okay, this requires some thinking. Okay, this is incorrect. This part is digit 2 position. Now color helps. Now it's better. Right? Yeah, the color helped. So given a number, you want to do some kind of loop. Every step you extract, the thing you want to extract is just a digit. Okay, every time you extract a digit, so the function takes this number, then it will output the function takes this number each time. It will output one digit basically. It will output the chosen digits and the position of that digits. We need that, which is the index of that digit. So the chosen digit, the position of that digit. Okay, so each loop, the function returns the chosen digit and position of that digit. Now this can be improved. Instead position of the digit, we in fact just need the remaining digits to choose from for the next iteration. Fantastic. So okay. So fold. Okay. So let's write a function. Document, write a function. Okay. Argo steps. We gonna do recursion. Write the function f. ff takes a list and return a list like this. Chosen digit. Rest list. Okay. New input list. Okay. So the function takes a input list and return a list like this. The chosen digit and the new input okay, chosen digit and new input list. Okay, so the function takes, so you need to make this function be the same for every loop. So the initial, okay, so this is about design of this recursive function. So instead of that, let's modify the function. Let's takes two args. Something like that. Okay, let me show you. God. Result list, input list. Okay, and return basically the same thing. New result list, where new result list has a chosen digit appended to result list. And new input list is rest of list to pick a digit in next round. Okay, so that is a design of our recursive function, logically laid out. Okay, so then we just gonna fold FF the result is the first part of that. Okay, let's write this function. Now this FF, let's name it pick digit. Okay, fantastic and beautiful. That's algorithm steps. Okay, so we're gonna write this function pick digit. So far so good? So good, very good. Okay, description. So we're gonna start. So we're gonna write the function. So let's put let's clean up a little bit. Okay, so put the code back. Wolfram, paste it there. Let's make the comment. Experiment. Okay, so the code will roughly have this structure. These steps. Okay, then this argo description. So let's do that. Let's syntax correct, showing browser. So first of all, we experimented. Then we have the outline of algorithm structure. Then we can write it. Okay, then we now code. Okay, so next, so now remove this. So what pick digit? That's a function. Okay, so the function. Now let's copy that so people can see. Okay, pick digit is a function. 2 arguments. Okay, so Now Wolfram language, by default, I mean by convention, any symbol starting with capital letters are built-in functions. So all built-in functions start with capital letters. So your own function always start with lowercase letters or variables, okay? So that's a convention. So result list and input list, okay? So what you're gonna do, so it will, let's see, it will, so now we need to copy this code that we have. So this is the function, we need to do something like that, okay? We don't need that. So digit list. Now let's rename this to digit list, shall we? Now in the end, we need to do, okay, fold, pick digits, result list is empty, and the digit list is, let's take an example here. Wait, let me show you, okay? The function is simply pick digit. Initial condition, 2 arguments. Oh, so initial condition 2, well, okay, the initial condition takes 2 arguments. Okay, so, well, so the result list is empty, and the digit list is gonna be this drop 11. Okay, let me show you. So initial condition, yeah, initial condition, and the digit list is gonna be integer digits. Okay, copy. So do you guys see what I'm doing? Yes, do I make sense? Am I like going too slow? Or integer digits? Okay, so integer digits, so fold by that function, and here is the initial condition, and oh god, god, oh, what am I doing? So initial list is input list is integer digits. That's right. Does that make sense? So use that function. Initial condition, I mean initial input to the function is this thing. Wait, it takes it just takes an empty oh, okay, so wait, don't tell me what so actually right, so it's gonna be like that. the final result. The final result, I mean, this is just for one digit, okay? For one number, one input number. You turn that into integer digits, then drop the rest 11 elements. Then you apply recursively this pick digit. Initial argument, first argument is that, okay? Yeah, I think that's that. Make it one line. Now we need to write this pick digits, okay? Result list, digit list. So what you're gonna do, so let's okay, so remove that, in fact remove that, okay? So make it people can see. So the function takes two lists, result list, input list, result list, input list, okay? So you just apply max, okay? So max at that, you don't even need to drop. Okay, so let's make a local variable, local constant, okay? So okay, choice digit equals to max digit list. Okay, you pick one, then what do you do? Then you just push. I mean, you return. Okay, then you need to you need to know position. Okay, with again, let's just say digits. Let's not to get wordy. Okay, position equals to position equals to, do we have the position? Yes, we do. Something like that, somewhere there. Position equals to position position x digit. Wait, so wait, this is position of x digit from x digit list. Let's turn that input in. Let's change that into input list. Okay, rename. Save, close, reopen. Now input list, result list. Okay, so digit equals to that, then position equals to that. Is that right? Okay, then what is your expression? The expression would be, you need to return, remember, two things. So the first thing is append result list X digit. Fantastic and beautiful. The second part is the drop thing. Okay. Let's the second part is drop input list and okay, I think that's it. Drop input list, flatten, drop the first from 1 to the position. I think so. So can you guys see this code? Does that make sense? This code. So if we copy it, begin Wolfram Language Notebook. Question: Lemon Leaf says thoughts on Apple's RAM prices, and they are huge scam. Okay, that's about it. Apple, you pay for the brand name, you pay for the convenience, you pay for the trustworthiness, so you don't have to spend time on these issues. Like if you are not a computer savvy person, most of us are, but majority of the population, they don't know anything about computers. They don't know what's a RAM. Okay. So they pay very expensive. They buy Apple. If you want 16 gigabyte RAM or 32, you pay like 2 or 3 times more than normally. But you don't have to spend time. You don't have to hire a computer expert. I hire you 1 hour for $100 an hour to tell me to advise me about which RAM fits in which computer, what is the quality brand of RAM, memory chips. And then you have to take the computer apart, put it in, you don't have to spend money or time on that. You just go to Apple Store. Here is $3,000. I want 32 gigabyte of RAM, On the other hand, so that's the brand, that's the point of brand. You can trust Apple, but you have to pay. Okay. So it depends on you. But if you know about computers, then obviously to you, Jesus, Apple is charging 10 times more. Jesus, my God. So you go to store, you assemble your own PC, cheap. But you spend 2 years to study about computers. That's what you do. So that's trade-off. Okay, that's trade-off. But to a lot of these people, we would think, oh, Apple is like a scam. No, they didn't force you to buy their stuff. You see, it depends on you. You have a choice. If you don't know computers, it's like McDonald's. You go to anywhere in the world, you see McDonald's, let's say in India, you can go there and eat. You can be sure it's safe. But otherwise, because there's a name, McDonald's, trust, it's a brand. They guarantee, you can just. So on the other hand, you go to India, somewhere you don't know, you don't speak the language. There's a restaurant. How can you be sure? You go there, maybe they kidnap you, something happens, right? So that's the purpose of brand. Okay. Anyway, I learned this from Thomas Sowell, Basic Economics. So it's contrary to the popular belief, oh, they are scamming money. Well, you don't have to buy theirs. They serve a purpose for different. So in this way, you have brand names, you have unknown names, you have knowledge people, you have so many choices. Depends on you. So you can have the best choice. Okay. So this Wolfram language, so that's the formatting. Okay. So wait. So you don't want this semicolon. You see, Wolfram Language, you don't want that semicolon. Delete. So that's a code. Okay, let's magnify. Can you guys see this? Can you guys see this dynamic real-time formatting? Beautiful. This technology has been around since 1996. Wolfram Language Mathematica version 3, 1996. You see, smart formatting on the fly in real time. You see, instead of the Python idiots, the C, C++, the Rust idiots, the Haskell idiots, let's format, let's indent, let's decide, let's write a programming style guide. Let's write a 202 format, the fucking idiots. That's what I call industrial coders. They don't know about this. If you want Wolfram language, you have to pay. Very, very expensive, but there's a free version you can download, okay? So I like the Retina screens, but still using a ThinkPad. C is fine. No, C is not fine. C is the worst damage in computing history industry. C, then came C++. They are the worst. They are the virus, You see, C is a virus that it's like a cancer, malicious cells. They grow like, how do you say, cancer cells? They grow. So C created C++, C++ and C, and then they created JavaScript. They created Java, and they created JavaScript. So there's a shit piled on top of shit. The syntax and all that. That's the damage of C to the computing industry. C++ is worse than C. Yes, of course. Now I can tell you are not a functional programmer. So anyway, so like between the non-functional programmers among the C and C++ and Java or C#, those type of people, this constitutes the majority of industrial programmers. May it be web dev, may it be Linux kernel, may it be drivers, whatever. So most of them are imperative or procedural programming language, coders. So to them, a lot of them say C is far better. C is the best. C++ is the worst cancer cell. Okay, to some degree, that's true. I mean, I would say that's true. But to those of us, I grew up, like, my first language is Wolfram language 30 years ago in 1993. Okay, this language I'm coding. So I've been coding it for 30 years. So to us functional programmers, we consider C and C++ like the fucking same thing. The same shit. One is just a bunch of shit piled on top of other. C is the shit here. C++ is this piles of shit, okay, on top of C. And they go by, oh, we are the most popular. We are compatible with C. C++. Fuck the Benjamin Stropes. Fuck. The most damage to computing industry and Unix, C and Unix, they bootstrap each other, like C, Unix, C, Unix, C. Fuck them. Okay, let's go back to this code, okay? Okay, we already spent 60 minutes. Okay. So do you guys see what I'm doing? So actually, so we don't need that. Okay, so this is so I need to do some indent so that the code become more readable. Okay. Now double check. I'm not sure this is correct. Okay, but first of all, we need to clear. Okay, so let's see. Pick digits, result list, input list. Digit equals to max from input list. Then get the position of the max of the x digits. Okay. Get the first position of that. Get the first position. Then, okay, then you return this pair. The first is append result list, append or prepend. Append. Okay, yeah, we want to append. Then the second result is you drop from the input list. You drop the beginning, right? You picked something like that. I believe so. Okay, let's try it. So if you do that, then let's say, yeah, now you need a number. Okay, so if you do that, so let's, we don't need you anymore. So now you pick a number. So let's say that. Okay, so actually you need this part. Okay, so do it. So in the beginning, you got this choice, A1, A1, okay? So you need to feed that into, that's the input, and the beginning result is empty. So let's run this code, okay? Do I make sense? Are you guys following this? Okay, so let's select all, paste, and shift enter. Fantastic, it picked 8. Wait. Wait a minute. It picked 8, but we truncated the whole shit. Oh god, that's not good. So we cannot do this. You see? Do you guys see what I'm saying? You cannot on this first step remove the rest 11 items. So you need it to be intact. Oh, okay, so I got it. So you fold, yeah, so that's the first step, but wait. Wait. So I know. Wait, I know. So this fold, what we should do is, okay, we don't want to drop there. So okay, then the second part is the initial step. Okay, so we need to do the drop as an initial step. Oh god. No, you can't. So do you guys see a problem we are having? Oh shit. So OOP is the issue. I think yes, OOP. I do code in functional languages. That's fantastic. I use OCaml mostly, fantastic, and Lisp recently, fantastic. Okay, shit. We got into an issue here with this recursive function. So we need to think about the design. So because you see the first step is different from the rest. The first step is that given a list of numbers, you need to truncate. You need to take the previous so this design is not good. So the function should return the position instead. Should return the position, not the input list. But let's make sure. So you begin with the list of numbers. The first step is truncate the rest 11 of them. Then you pick. Then you need to rest them back. Then you need to truncate. Okay, so the truncate step. So initially you should do this. Okay. Then the what? So the function takes this you pick from. You see, because the first step you have to truncate the tail of the list, but every subsequent step you have to truncate the head of the list. So the first step is special. So when you can have them special when if you want to use a recursion, unless you manually hard code the first step, then you do the recursion for the rest. So what should we do? One, to make them in sync, to make them not special. That's one step, one way. Or just manually do the first step, then apply this recursion to the rest, to the subsequent steps. Okay, so there are two approaches. Now, which one is better? So what if the sequence always feeds on the input string? The input string is not large anyway. I mean the input list. But it would be not efficient. But then again, advent of code doesn't give a fuck. So if the function always takes the input string like a global variable, then all it needs to return is basically the God, this is not good. Fuck, this is now 70 minutes. Anyone is watching 7. Fuck, we digressed too much. It's not good to digress when you cannot solve the problem in 1 hour. Yeah, we can solve it. Just need to concentrate. I don't want, I want to code this efficiently. I don't want sloppy, I don't want to just assume, just let the function take the original list available, I don't want, because suppose, the given list, the integer digits is like 1 billion, then you get fucked. Yeah, but the end of code doesn't care, so So only the first step. So if you truncate, so the first step you truncate the tail, but then you need the tail. So but what if each time the function returns a position and something like a position or okay, so you do have to manually do this the first time. Very interesting. How can we elegantly make it one function, one single recursive function? But there is the exception of the first step. The first step is you have to truncate the tail. Alternatively, right, the first step you need to truncate the tail. Then subsequent steps you need to truncate the head. So you got these incompatible, you know. So how do you need to distinguish the first step versus the rest steps? So one way, then you just hard code the first step. So if you hard code the first step, yeah, you can hard code the first step. Yes. So if you hard code the first step, then what does it look like? Something like that. Okay. No. Because once you truncated the tail, it's gone. The function don't see it anymore. But then in subsequent steps, you need it. So if you want to hard code it, then you basically, okay, so here is how you're gonna hard code it. Okay. Let's try this. Let's see. So you call pick digits empty initial result, and the starting list is gonna be that. Okay. Then this is the first result. Okay. Then you fold. Hold on a second. So fold, then you fold, pick, then something like that. Okay. So if you're gonna hard code it, maybe this. Okay, this part would be, hey, this part would be, hold on a second. So this part would be not that. Okay, it would be something like, then you need position. Jesus. Jesus. Okay, this part would be position of Okay, so it's gonna be like that. First, then fold 3 arguments, the function, first result, and that. Okay. So you do this until the list is empty. That's right. That's right. Wait. Right. You do this until the list is empty. No, no, no. You do this until. God. Very annoying. Oh, God. Okay, this is very annoying. You do this until the. Oh, God. Lots of thinking. You know, when you do a loop in functional programming, it makes the problem much harder. Whenever you do a loop, and when you want to do it in a functional programming style using recursion, that makes the problem harder. Okay, so the first step, let's see, the first step, it's not that bad. So what are we doing? Okay, so the first result is just that. Okay, so not that, so we need to do that. Okay, and so can you guys see? So you see that you need to first result. Actually, oh God. Actually, you are incorrect. You need this first result variable because it happens again with the position. So this is what happens if you want to do the first step manually. Okay, but then pretty ugly. I mean, this not. But then, so can you think about? Can we just make this one function recursion then? So you pick the first digit. Very simple problem. Very simple problem. Position. Okay, let's think about a new approach. Is there some other way? You know, you're just gonna get What? You just have a bunch of digits. You want to pick 12 of them. So can't you just pick a maximum? Oh yeah. You just got a bunch of digits. You just want to pick 12 of them. So you just pick max 12. What's wrong with that? What the fuck do you need to do recursion for? Just pick 12 numbers. Oh god. You know? Do you know? Do you know? Do you know? Do you know what I'm saying? So wait. So if you just got that integer digits, you got this big wheel of fortune. You got this big, then you just max 12 of it. Okay? I think Wolfram language has that feature. Yields the numerically largest of x. Yields the largest element of any of the lists. Oh god. Take largest. Okay, there. Take largest gives the n largest elements of data sorted in descending order. I don't want sort. Okay, so take largest, they came about in year 2015, 15 years ago, this function. Okay, take largest. So what if you do that, then take largest 12. Okay, return. In this case, it's all 9. This case is not interesting, so we need to have a interesting case. What about that? Okay, so what? Okay, so copy, paste, delete, there, run it. Okay, so you got that, but what do you mean by, you see, it reorders them in descending manner. That's not good. So let's do a simple example. Let's say just take 3 of them. Let's say 1, 2, 3, 9, 7. So in this case, it should be 8, 7, 9. Okay, so we you see, we don't want to reorder it. This is a better approach. Then sorted in descending order. I don't want to sort. Okay, is there an option that prevents it from sorting? If so, then it's good. Wait, does this actually work? Does this actually work? A7, take 3 digits, right? You take the largest. 9A7, but you don't want reorder. Oh, so fuck. You see, you got them so built-in functions. It's all written for you already. So take largest by, let's say maximum by, return a list of elements E of data for which the value fx is maximum, a list of elements for which that function is maximum. Okay. So position largest, give the position of the numerically largest value of list. Okay, give the positions of the first and largest values. First and largest values. So suppose one of them is A9. So the order should never change. So each number 8, 9, largest. So you just pick largest. And 12 digits. Yeah, so this should work. Yes. Position largest, that's what you want. Okay, that's you want. That's what you want. Okay. So no match. Jesus, this function is new in 2022. Oh God, so we are using like new functions. 2022, 3 years old. Interesting. This function is new in 2022, so we are actually using new functions. So okay, that will return A7, 9, the position. Okay, so then you just take you want to extract element by position. So how do you do that? That's either extract. Okay, so look up the documentation. Extract, yes. Extract by position, yes, exactly. So what you have to do is just that. Extract this list by this position. Okay, that should be A79 exactly. So this one single line of code does it. Okay, so let's try, for example, now let's try the huge number. Does this what's this 9999? Oh, 993 4 5 6 7 8 9 10. That's too many nines. Okay, so what about that? Search for 1 2 3 4 5 6 7 8. That's too many nines. We don't want that. We want let's say that number. Okay, so position largest, this huge number. Okay, let's say number equals to that, Actually, let's just do that. Okay. So that's a long list. Okay. Then that just that 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 12. Okay. Run it. Oh, because we didn't evaluate it. Okay, so delete, you need to evaluate this together. Otherwise, X list is not defined. There it is. Wait, depth of object. What? Why is that? I don't understand. It works here. And logs there. So why is it not working here? X list equals to that and run extract that. Run it. Okay, you got a problem. This is not good. This is not good. You got a problem. What is the problem? I don't know. Why can't you just do it? Okay, suppose that you made it shorter. Do you still have a problem? Yes, you do have a problem. Depth of object is not sufficient. What are you talking about? Well, if you're running Wolfram notebook, it will be much easier to see. Paste, what is the problem? Okay, so let's see. Shift enter. Now, what is the position largest? That's the question. Oh, it started to give a this kind of thing. Okay, you need to, so it started, it's not just position, it starts to give repetition, gives the positions of the numerically largest values in list, gives the positions of the first n largest values, okay? So So if you say three largest values, why is it 42315? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh. Two and 4 position of largest. So if you specify a second argument, give the positions of the first n largest values. So it returns a result of 3 elements, okay? So if we do this, right, it gives a result of 3 largest, okay? The second element, then so there is a repetition for 2. Wait, this is not good. The result is not consistent. Because in this example, the result, each element in a result is not actually a position. It's, you see, the second element of the element is actually the time it repeats. 100, 200, 100, 200. 1, 2, 3, 4. So 200 occurs twice. Oh, wait. So oh, wait. So 4, 2, 4 and 2. Oh, okay. So when you extract, so I think I got it. So instead of that, so let me show you. Okay. So integer list x list equals to that. Okay, let's run that. Okay, you got that. Okay, then you say position largest. Okay, then you get right, you get that 612. Okay, then you have to then this part is actually wrong. What you have to do is that you x lists. Okay, then you need to actually map extract function to this position largest. Okay, so this is x list. Okay, so delete that there. Okay, so can you see what I'm doing? Run it. That would be 98. Okay, wait, no. It should be 987. Why is that? 6. So largest is 6. So it again it reordered. But I don't want it ordered. Shit. Oh god, this may even be the problem. I don't want it ordered, okay? So what we're gonna do now, I think we're gonna take a break. Okay, take a break for 10 minutes. Oh god. Okay, ISO date 4. ISO 4. Do I have people watching? It's annoying problem. 2. Okay, well, people are good. Well, okay, we're gonna be back anyway. Okay, I'm back. Now this problem is very simple, but so given a list of numbers, you just want to take 12 maximum number of them. Okay, so what is the position largest? First and largest values. Okay, so let's just study this position largest. Okay, let's just study this position largest. Let's say, let's introduce a repetition. Okay, so position 6, 1, 2, 3, 4, 5, 6, that's 9, that's the largest. Okay, then second largest is 1 and 3. So you got that 3 and 1. Okay. So they are, do they return the position? They don't return the position, they return the index. By default, compares values by numerical magnitude, returning a list of positions of the largest value. Okay. Gives a single list of the largest value, gives a list of n sublists for n largest values, a list of n sublists for n largest values, or as many as are available if fewer than n. Okay. Expect all objects to be comparable with one another based on the ordering function. Okay. So they actually do not return the position, they return the index. Okay, let me check again. So 6 is the index, that's right. 6 means 9 here. And 3 and 1 is index, that's this number 8. And 2 is the index. Okay, so they actually return index. Okay, so in order to extract them, you need to use parts. So parts x list, then you let's see. Okay, 6. That should be 9. Okay, so map. So you got a bunch of indexes. Flatten. You got a bunch of indexes. Okay, you flatten. Okay, so let me show you this thing. So you got a bunch of indexes. It's position. Okay, so flatten. Okay, that's what we want. Then we want to sort. Now we want to sort in a reverse order. Okay, because we want to order them by their index. 1, 2, 3, 6. So 1, 2, 3, 6. That's right. Sort. Oh yeah, we don't want reverse order, so that's perfect. Then we just part extract. Okay, so that's what we got. Okay, so these are the position largest 3. Okay, so these are the steps. So effectively, we have found out how to do it. Okay, then we repeat this into condensed way. Okay, so let's see. X list equals to that. Okay, then and that. Okay, okay, that's right. That's right. These two are identical, are they? Oh yeah, the number. Okay, so we got a number. Gotta be careful. We got the number you need to use this number, not that. Okay, so that number get the position largest. Okay, then you flatten okay, so that's okay, then you got a flat list, then you just sort. Okay, so simple. Then you sort, then you take the part. Okay, so that is a sort, and this part is X list. Okay, just like that. Run the code. A729, beautiful and fantastic. Okay, now and now combine, so you don't need that variable. Okay, run it. As simple as that. Fantastic and beautiful. Now now what are we doing here? We're doing extract. Forget about that. Okay, okay, so I found issue with Wolfram language because there is, according to me, appears to be a inconsistency, because in Wolfram language, the concept of position and index are different. Okay, so let me show you. So given a list, you have the concept of index, which is familiar to everyone, to Python, to JavaScript, to almost every language. You have index of a list. So in Python, for example, and JavaScript, they start with 0. So 3 is 0, 4 is 1, 5 is 2 in this example, 3, 4, 5. So that's the index of the list. Now in Wolfram language, the starting index is 1. Okay. However, Wolfram language has another concept besides index. Okay, so here you got an index to an element. Okay, that's one concept. Now, what if your list is nested? So if you want to specify this element, you have to say, the first index, then the second index. So you use like nested index, and that is called position. Okay, so given this nested list, So index 1 is A, the element A. Index 2 is this, like this whole nested list. Index 3 is E. Then you can go down further. So so in other words, position, the concept of position in Wolfram language is a list of indexes that allows you to identify a specific part of a tree, a branch of a tree, of a nested expression, okay? So it's very simple, nested index. So, I mean, list of indexes. So when you have a single index, that's an index. But when you have a list of indexes, that is called position of a expression or sub-expression, okay? So when your expression is a nested list, you can identify any specific element in this nested list by using a list of indexes. And that is called position. Okay. So remember two concepts, index and position. Index is a single integer. In Wolfram language, it start with 1. Now, position is a list of indexes. It's a list. Okay. So two concepts. Now, but the Wolfram language, this function PositionLargest, okay, this function is new in 2022, 3 years ago. The result it returns, as we can see here, PositionLargest. The result it returns is not positions. Okay, position means list of indexes. The result it returns is a list. It's just indexes, but grouped. Okay, so for example, this list 3.1 does not mean it's at index 3, then of that expression index 1. It does not mean nested index. It just means there's an index at 3 and there's another index at 1. They group it because this is the second largest, you know. So this function name, PositionLargest, is a bit inconsistent. It's a bit confusing, okay? Yeah, it should be largest, index, it's not position, because Wolfram language do make this distinction. So that's my impression. But I know that Wolfram language is very meticulously designed, and this is 2022. Stefan Wolfram goes on YouTube, talks about design every week. Wolfram language new features. They a bunch of Wolfram language co-workers, designers who implement Wolfram language. They talk about, they go over about the design of new functions. So this function in 2022, I suppose, is very carefully designed. So I could be wrong. Likely, I don't know, but but you see, Wolfram language has grown so large from 7,000 functions. So why? So my question is, why is this function called PositionLargest? Why? Because I mean, what would be a better alternative name? Because there are many constraints. You see, when you say PositionLargest, people kind of understand what it means. But if you want to be, like I thought, consistent, then you have to name it indexes group of the largest, something like that. So it's very tricky. But my point is that what this function returns is not position technically. It's just a grouped list of indexes. Okay, do you guys see what I'm saying? No, you don't. I don't think you guys are paying attention, because right now I have like only me talking to myself, I think. 3 people. Okay. So anyway, we understand this position. Yeah, position of all largest randoms. Take largest. Oh, there is another take largest. Did we explore that? Yes, we did. So we can think about the optimal approach, but basically we already, this line is a solution. Let's just do it, okay? So this line is a solution. So all we have to do to solve the problem is just this line is a solution. So what is our so forget about that, okay? Integer. So we are exploring take largest, okay? So okay, and turns out position largest is what we want, and just that code. And what are we doing here? We can actually delete this part. This part we were using extract because I thought the result are positions, but they are not. Okay, now let's just work on this code. So okay, let me do this. Okay, hold on a second. Let me do the cleanup so that you actually can see what are we doing. So this is approach we were doing before. This is approach. Abandoned. Because the first iteration differ from rest iteration. The first iteration needs to truncate list from tail. The rest iterations need to truncate list from head. Okay, so they are separate. So you cannot make it into one recursion. Therefore, you can not make them into one single recursion. You need to either do the first step first manually, then recurse, or redesign your function so that they are consistent, like so it does not have this issue. Okay, so let's put this back. This is our first recursive approach. Experiment on the final recursion. Okay, so put it back, syntax color it, and you show it. It'll be very clear. So first of all, we did the experiment to see the nature of solving the problem manually. We create digit 1, first digit, second digit, third digit. We have to do it 12 times. Then we try to condense that into one recursive function. And this is a design of the function. Okay. Then we realized the first iteration and the rest iteration are different, because the first iteration you need to truncate the list of input from the tail. Then the rest iterations you need to truncate from the head. So you need to, so that can work unless you work on more redesign the function. Then we realized this simple problem, you just take the largest, n items of this list. So PositionLargest is a solution. The solution is simply that line. Okay, so let's code that. Okay, so in fact we don't want TakeLargest, we just want position. Okay, use this. Okay, then here is our code, then here is our code, then actually we just start to solve the problem. Where's the input? And we have the input from, yeah, so the input is from yesterday. Yeah, there is the input. Copy. Okay, so okay, hold on a second. Compact it. Okay, so that's the okay, so that is the gist. Now I'll start a new Wolfram and just copy that. Now let me show you guys. Syntax correct, showing browser. Can you guys see? So we have a new section. We discovered we can use this. Then now we work on the final solution. Okay, so this is just this line. So this line, okay, let me just start to work on it. Final solution. Okay, we don't need this this drop. It's total. Okay, so actually total map, you need to map a function to the input. Okay, so but first input is the okay, so hold on a second. X needs its integer digits. Okay, run it. 9, you need 12. Okay, so the problem says 12. Run it. Okay, now copy that. Let's try a different number. 8111. Okay, 811. Run it. Fantastic. Now let's just try. And then you need to submit, right? So once you get that, you need to combine the digit to form a number. Okay, so from digits, I believe that's a function that turns a bunch of digits to an integer. Okay, so let's just say that. Run it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a minute. We only want to extract 12, but now we got more than 12. What's going on? What? 1, 2, 3. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why am I getting more than 12? I just want 12. Position largest. Okay. What's going on? Okay. Let's just say 4. 4. Then 5. So, okay, this is not a good number to begin with. Oh, okay. So you need to limit. That's right. Because when there is a repetition, do you guys know what I'm talking about? You see, when there is a lot of repetition, let me show you this, okay? So let's say we just want to pick 4 numbers out of this number, okay? So when you do that, when you call position largest, it gives you 4 largest numbers. But however, in this input, the four largest number there would be 9, 8, 1, and that's it, because there's no more largest, okay? So the third largest, the number 1, is actually repeated many times. So this position largest, in fact, returns, do you guys see what I'm saying? This position largest actually returns, let me show you. Okay. Wait, syntax invalid. What? Oh, you got extra. You see, it returns more than the 12 numbers. So what you need to do is you need to truncate. Okay, so you can the way you truncate the number is you can first of all flatten it, then take this input, then you just say 3. Let's say 3. Okay, then you just get 3 indexes. Okay, so if you say 5, then you get 5. Okay, so you basically you need to do a take. You need to do a take something 12. Okay, so let me think about this. Sorts. Function. Function. Expression. Take x12. Okay, so that would be the function to apply to. So you put it there at, okay, you just take the first 12. Okay, so if we run this, result is gonna be identical for this case. Oh wait, yeah, right. You see, fantastic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. Okay, now in this case, it's the same number as before, so delete that. In this case, you need to add the take. Or let's just copy this and put this number there. A1 completion, delete that, run it. 12 digits, beautiful. Okay, then you don't need, then you don't need this, and you don't need that. Then you put from digits in front of them. Wait. Okay, then it will return actually a digit. Fantastic. Okay, fantastic and beautiful. Run it. Fantastic and beautiful. And let's try a different number. So copy. So next number 2, 3, 4 completion. Do it. Fantastic and beautiful. Okay. So now let's just combine them. You don't need, what? So what are you doing? So delete that. Yeah, so you just so all you have to do is now just, let's see, this is gonna be a beautiful solution, even though we spend like 2 hours. Total map a function to it. Okay, so this is a function we're gonna map, and we need to, because it's a function, so we need to say function. Okay, function, then the expression part is this. Okay, and the input is xnum. Okay, so xnum, the input is gonna be xnum, map that to input, so each input is a number. Xnum, you need to turn xnum into a list. Okay, so let's with x list equals to integer digits at xnum. Okay, then cut. Then this is the expression. So do you guys see what I'm doing? So that's it. So this part is a sample. Okay, and this part is a solution. Okay, so in fact we don't need the sample. Okay, if we run this, it will then you need total. Yeah, so we added. So in fact we can run this. Can we? Yes, I think so. Let's check one more time. Xnum is the function's argument. So first of all, turn xnum into digits into a list. Then you do this. And so run this. The result is going to be, what is the part 2? Okay, the result is going to be 31219 something. Okay, let's see. Run it. Okay, incorrect, you idiot. My result is not his result. The total output voltage is now much larger, 31219. Okay, my result is not his result. So let us from digits. Let's not use the total. Let's see what we get. Okay. So that is our result. 987 811 234 987 811. Oh, 434. We got 234. They got 434. There is the problem. Oh, okay. So then A18. Then the result is A89. We got A18. That is incorrect. So let's focus on that input. Okay, interesting. Tricky. So if you have this number, what you get? A18. Wait, it should be A89. Okay, the result should be A89, A89, but you got A18. So why? Oh, okay, there's something position largest. A1, A1. Oh God, this is tricky. So position, you get their positions. Then flatten. What does this return anyway? So then you don't want to sort it. You don't want to sort it. Okay, I know what to do. Okay, so right. So you first do that, then take the first, and don't sort it. Why are you doing sorting? You should not. Right. So your code only splits the beginning of the values. No, I don't think that's a problem. But look, I think I got it. So so this number, you don't want that. You just don't sort take. Yeah. So let's run this. Let's see. You see, wait, 988. Oh fuck. Wait, why is it 9? Position largest. Okay, now you need to think about position largest. No, okay, you need to sort somewhat. Oh god, nasty. You see, for this number, the solution should be 8889 Okay, 8889. So what is that you want to do? So let's see. Position largest. Okay, returns that. Then you need to sort though. You need to first of all take okay, so you need to first of all flatten then truncate. Okay, in fact, does flatten has option of truncate. flatten to level and flatten sub-expression. No. Okay, so you flatten it, then you take the first 12. Okay, then you need to sort because the first index, those with less index come first. Then you need to sort that. Okay, beautiful. Do you guys see what I'm saying? So this is wrong. So let's run it. A9 something. There it is. Beautiful. Okay, so now you just copy that and replace this part by that. Okay. Then we run the whole thing. It'll work. Well, let's comment out first. Okay, so now we run the whole thing. It should work. Run it. So 9876 check. 9876 something 1 check. Then A1119 A1119 check. Then 3434 something 278. 434327. Okay. Wait. 4342. 4342. But we got 3434 fact. Then the last one, A8891. Okay, I think I know what's going on. The last one is correct. Yes, but the third one we got wrong. So we have 34343. The solution should be 4342. Okay, very tricky. From this example, you can see there's a lot of attention went into creating this puzzle. Okay, so I kind of know what to do. Okay, so basically it's a sorting issue. So you want to sort like you want to you want to flatten it for sure. Okay, so this part, this line flatten is so sure for sure you got a bunch of indexes. Wait, not sure. Okay, so well, yeah, this is oh god, this is a lot work to do. Okay, copy. Now let's try this new number, this magic number that fuck you up. Okay, now run it. You get 3434. This is a tricky one, but according to the result, correct result should be 4342. Okay. I still don't know if I like the syntax of Wolfram or I hate it. Yeah, I don't know neither. But I can tell you for the first 20 years, I think it's the best possible. But now I'm not too sure because it's super flexible. You know, you can make the whole thing just like a Lisp. You know, so all these special syntax like the @ sign or the braces all can be changed, so you end up with just purely nested square brackets with comma. So the whole thing, so you know, I can show you, but anyway, it'll take a minute or two. So you basically it's like a list. Okay, so you like kind of like that, but even here you can change, for example, this add, you can change it to just that. So that's a standard form. So it became fully nested thing. Anyway, so that's anyway, let's get this to work. Okay, so So this thing, so the tricky, I kind of know what's going on. So you see, this position largest return this grouping of list. Okay, so you want to know first of all how many items are there. If it's 12, then it's perfect. Okay, but let's see, 1, 2, 3, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see, sometimes you got more. So when there are, so the when the result of this position largest is more than 12, when you after you flatten it, then you need to truncate certain tail of these subgroups. So in this example, these subgroups, you need to truncate those A642. Okay, then actually the problem example is here. Okay, so so what does this return then? Okay, so God. Let's try. Let's see what that returns. Let's see. Actually, you can just put it there. Okay, so there. You see, it returns that. Now this, let's just do this here too. Okay. So now, so how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's more than 12. When it happens, there's more than 12. You need to truncate beginning by, you need to truncate some of these subgroups. Oh God, that truncation would be tricky. So within a subgroup, God. Okay, this is pretty tricky. So within a subgroup, you actually want to not truncate. You want to remove the head. You want to remove the largest index. So you need some kind of recursion. So check the first largest if there's enough, if there's more than 12. If not, get the next one. Total, are there more than 12 digits? No, then get the next one. Okay, for each one of these subgroups, first of all, you want to sort it. So you need to apply to, can you sort the whole thing? Let's see. What happens when you sort them like that? Okay, no, so what you need to do is you need to sort you need to sort it like that. Okay, let me show you. Yeah. Then you need to flatten it. Okay, let me show you guys. So by the way, that /at, that just means map this function to that expression. Okay, so once you get that, you flatten it. Okay, then you take the first 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, then you take the first 12. Okay, so that means let's just trial and error. Okay, let's just trial and error. So what are we doing is you get that, then you sort to each. Wait a minute. You can't. Okay, wait. So here I know what to do now. Now for each of these number is an index. You need to start from the smallest first. For example, here it would be 1 first, then 2. Wait. Oh God, this. Okay, I'm like suffering from this problem because this needs thinking. Okay, you can't just trial and error because then you might go on and on. Because I thought we got this fantastic function that will just solve the problem in one line, but then there's these issues now. Then you need to think about. But basically, it is kind of the thing. Okay, so then you need to think about again. Then it's almost 2 hours. Or was it 3 hours? Shit, I need to take another break. Yeah, I need to take another break. So position largest, that's the largest number there. Second largest, third largest occur 4 times, okay? So that's what you want, but so all these, okay, so among these numbers you need to you must take only 12 of them, okay? There's 5. Okay, you must only take 12 of them. The rest must be deleted. The question is which one to delete and what is the order, okay? So the question, so the order would be the smallest index first. So wait. Not exactly, okay. Oh God, I thought this would give you the solution already. Position largest. Beast says, I think it's basically what you already do, but here is how I would solve that. Give a unique index to every number. Then do a sort on the list of unique ID based on the value they point at. Remove the last 3 digits from the list of unique IDs. Yeah, I think I get what you're saying. It's basically what you already have, but give a unique index to every number. So you mean combine the number with the index. Then do a sort on the list of unique ID based on that value they point at. Then remove the last 3 digits from the list of unique IDs. Go through the value, check if their unique ID is still in the array. Okay, I think I think we might be thinking, I mean, I get what you're saying, but not the detail. So I think, yeah, I think we pretty much know what to do, but it's just fuck. I want to take a break. Oh, the end of code is such a pain because every time I do it, including last year and the year before, I thought I'm gonna finish it in 10 minutes, but usually many of them ends up several hours and it's not done yet. And then I'm thinking, why am I doing it? Because it looks bad on me. Like, oh, you don't, like you are not expert. And then the other thing is, then it's like wasting time. I got lots of actual coding things about Wolfram language for my website I need to do. But then you end up spending like hours on this like problem for problem's sake, for nothing. Oh shit, advent of code. I need to, so this problem, I have to think about it. I think about it, I cannot talk. If I don't talk, I cannot do live stream. So it's like, I'll just need to stop talking and think for 10 minutes. Position largest. It returns the largest first. So, but the problem, you want to pick 12 digits in order. Okay, so cases. What about other ways to pick 12 numbers? Yeah, another way. Okay, let's digress. Okay, let me just, do whatever thought flow. So another way to pick, given a list of numbers, like a digits list, another way to return them is you select by a functional criteria, or you can use cases. Okay, for example, look at select. So you have to give a function that will pick out values, but in this case, select is not applicable because in order to determine which digit you want to pick, you need to judge there are several dependencies. One of them is like you see, when you select, you need to select 12 of them. That's for sure. And but what's the judgment? The judgment must be that digits must be one of the first 12 largest, like between 1 to 9 or 0 to 9. One of the first. Okay, so the criteria is they must be on the leftmost first and the largest. So leftmost is the first criteria. Wait, so leftmost means the element has the least index. The index is the least. And then you can do that with select because, first of all, the total result must be 12 of them. And select has no way to determine how many results it returns with the function, okay? So how do you logically describe this situation. Select is like filter in other languages in Python. The function has no way to know how many results to return. Okay, you need to like return 12 results maximum, and but you can return more though, of course. But then you need to the criteria is that. So in other words, how do you describe this problem of selecting 12 digits from a list of digits in terms of a filter? Is that possible at all, first of all? So this is an interesting side question, side quest. Is it possible to describe this problem in terms of a function that determines whether element must be part of the solution? I think I think I think technically yes, but the function needs to know. Actually, no, because the function needs to know how many. It needs to know how many member has already been selected. You see, it's kind of that way. So no, it cannot be done with select. But how do you describe this in a logical way? In other words, describe why you cannot use a filter kind of select way to solve this problem in a logical way. We know we can't do it because the result must be 12 elements, and select has no way to know how many other elements has already been selected. In other words, the criteria, a function to determine a member is the item we want, is dependent on what items we already have. So you can do this select in one shot. In other words, you need to repeat this. So this is not. But anyway, so the other way is cases. Okay, now cases won't help neither because cases is using pattern matching. Cases is using pattern matching. So you cannot, so each element, so in fact, cases and select, they are the same thing because a pattern can be turned into a function. A function can be turned into a pattern because for a pattern to behave like a function, all you have to do is you add a condition to the pattern saying that the function must return true. So using a function and using a pattern are actually same. So in both cases, the select and cases, they are both just a filter function. They apply a function basically or a pattern to an element to see that's the one you want. But then ultimately you cannot do that for this problem. Okay. So analogous problem is max. The max function. Pick the max element of a list. That you cannot do with filter because so in that case you need to know all the elements when you determine a given element is the one you want. You need to know the rest of the element. Okay, so technically though it's possible. Okay, that's a digression. Okay, that's about logical analysis of these mathematical issues. But then you see, then Wolfram language has so many others. So for example, bin list, what is bin list? Delete cases. So collect, let's see, what does collect do? download the latest version of Firefox. Firefox is very annoying. Collects together terms involving the same powers of object matching X. Same power. Oh, okay. That's more mathematical. That's not what we want. That's like simplifying algebraic expressions. Okay. But what we want is let's see, together. Together is some kind of another type of sorting. Together puts terms in a sum over a common denominator. Oh, that's combining fractions. Okay. So, but what we want is pretty much this. I know from experience, what we want is pretty much this take largest by. Okay, so this take largest by use a custom function instead of our position largest. Okay, you see position largest. So I should have written at least with duplicate values. So, okay, I think you have great ideas, but I need to work out my own flow. Yeah, I just need to work out my own flow, because if I follow your algorithm, that's just like starting over. Yeah. Anyway, so I'm pretty sure this, you just need to do this take largest and you need to think about this truncate. So I need to think about that. Okay. So what you need to think about is this. So this thing. So first of all, you know for sure you just want 12 of them. Okay. So if this list is more than 12 of them in each element, then you need to truncate somewhere. Now, when you truncate, you need to, okay, so you need to truncate beginning with you need to take the smallest index first. Okay, so for example, in the first group, you take the smallest index. So for the first group, you check if there's more than 12 or not. If not, then you take them all. In this case, there's only one number. Okay, so this 15 means, it's a number way at the tail. So that's not what you want. You want this first one here. So again, it's a bit tricky. So like which to take, which to drop. That's a question, and the order. Okay. But the position largest gives you the largest item. So the largest item, let's see. So we can work in reverse. So the largest item. So right, and 12 of them, right? But there's no 12. Okay, so that's a problem. So can you actually have an option that you just say a maximum of 12 items instead of 12 different ranks? You see, that's the difference. Right now you are saying 12 different ranks, but it turns out this number only have 1, 2, 3, 4, 5, five different ones. So when you have position largest, is there okay, you can have an order function. Okay. So it gives you the largest, 12 of them. Then, now, can we ask, are these 12 of them, you see, when you say 12, it's the result is always gonna be more than 12 items, because the distinct number digits there is just 10. So the result is always more than 12. Yeah, so okay, so but which one should you choose? So if you go by the smallest, okay, now my question is, can you actually use this? Does this actually work? Position largest, Jesus. Then because now I'm thinking, let's go back to our recursion approach, because that's surely gonna work. We know, because each step we take out some numbers, remove the tail or the head. That works. But then we run into like separate the first step versus the rest step. Then we have an idea of using this like functional mathematical approach. But then we run into this this, so you need to think about which one. Okay, at least for each of these group sublists, you need to sort them so that the smaller one comes first. Okay, then you need to drop some items. Now, how do you start to begin to drop items? What's the order? What's the first item you should consider to drop? First of all, which of these group to drop? Then, once you found a group to drop, which of the number to drop? Okay, that's the two questions. Okay, we know for sure this list is gonna be more than 12 items, because the maximum number of different numbers digits is just 10. So when you select the 12 largest, it's gonna be more than 10 indexes result for sure. So which group to drop? First question, which group of these to drop? Can you come up with a criteria in a mathematical way? Alternatively, we can do a procedural way, then it's easier. Well, procedural way, then you go through each one of them. No, this is not good. Wait, such a simple question. You pick 12 digits. Why can't you just do it? Pick 12 digits. Do not reorder them. That's the thing. Because this position largest is like, did they reorder them? They did, because they put the maximum first. You see, the 15 refers to that 8 at the end. You don't want to reorder them. So if you don't reorder them, then what is that? Then basically you just reorder. Then you just have 1 4. Right. So, but okay. So I think. Okay, so new approach, new thing. So given this result, you you sort each sublist first, like that. Okay, you sort each what? Why is that return that? Let's do it again. Wait, not that. Okay. This is wrong. You don't want to sort like that. You want to map. So let's write this. Okay, so that's that. Then you sort each. Then you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you take. Then you flatten it. Then take the first 12. Okay, so did we? Sorts. Wait. So them. So them, then flatten. Okay. Then you take. Okay, so that's, I think that's that. Let's try that. I'm getting tired. I'm getting pretty tired here. Getting pretty tired. I don't know what I'm doing now. So can we just comment all this out? And oh, too many to comment out. So, but basically, I just want. Okay, let's just delete it. Shit. Okay, that's just that. Sort them, then flatten, then take the. Then flatten, then take the first 12, then sort again. Let's just see what we get. Did we did we get the right solution? That's like before. Hey, 2, 3, 4, 2, 3. No, that's, wait, that's incorrect. Should be 4, 3, 4, 2. This is incorrect. What? Sort apply to that, then flatten, then take the first 12. Okay, take the first 12, then sort, then take the list of the first 12 and form a digit. Then you are wrong, you are wrong. What about A1, 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 9? The last one, now we got it wrong too. Before we got it right, but now the last one is wrong too. Shit. So go back to what we're doing here. So we have to again think about this. It's 3 hours, almost 4 hours. Oh god. Yeah, no worries. Do your way. Okay. I'm gonna take a break. So you guys take a break or go off, have fun for the holidays, Christmas. And I think I'm gonna continue because as a matter of let's just finish it, continue. So I'll be back in 10 minutes. Be back in 10 minutes, okay? Yeah, let me take a break and let's see what happens. Test. Flatten. Sort each. Sort each. Flatten. Take 12. Then sort. Okay. I don't know why. Why is this? It's not do from digits. Okay, let's just run that. Where's the output? What? Run it. Okay, so 2, 3, 4. Now this number 2, 3, 4. If we take 12. So it should be 3, 4, not 2, 3. So there's priority in taking the first. Oh God, this. There is priority in taking the first. What the fuck? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So largest, 9 of them. So I'm thinking the position largest is not good. I mean where is the position largest? Maximum by maximal by a function. Okay, that's just maximum. Take largest. Sort by, reverse sort by. So another way is you get the take largest. Oh God. So position largest. Where is position largest? . first and largest values. All the function position first and largest values. Position largest, okay. Okay, so we are using position largest, and it's not. So we are using position largest, but the problem is that it always return more. So even if you say position largest, even if you say position largest 10, that's gonna return same thing exactly. You see, it returns exactly the same thing. So position largest, okay. $13, 10, so 15 is 8, 14 is 7. Then the third largest number is 4. 4 occurs in 3, 6, 9, 12. Okay, so, okay. So you want to sort it first. Okay, so wait. So let me do this. Let's see what we get. Right. So right. So this 11 moved up. This group moved up. You want to sort by, you don't want to sort, you want to sort by index or length. God, it's tricky. So yeah, I'm pretty sure you want to map to sorts. That's what you want. Okay, so map number, so 12 from there. So 6 1 4 1 4 1 would be wrong. So in this example, our number is 2323. Okay, our number is 2323. According to the solution, the answer should be 4342. Okay, so 4342, that means the first item is index 1. So from this one, wait, 4 is index 3. So index 3 is from here. So if you just sort them all, then takes the, so eventually at the end, the index must come in order, smaller first. So you just flatten it, sort all, then take the first 12. What could be wrong with that? Okay, so if you just take, this is not good. So if you just take, just flatten the whole thing, then just take the first 12, then flatten the whole thing, then sort it. Then just take the whole thing, what you get. Okay. What? Which is still incorrect. It is incorrect because you got this 2, 3, 4. Okay. So it is incorrect because you got this 2, 3, 4. That's this from here, the number 1 problem. I mean that one index is incorrect. So why is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? And 1, 4. Okay, 1 is this number, 4 is this number. Okay, so let's do this so that it's okay. So right, returns exactly the same thing, right? Then you, so if you sort, let's see, 7, oh, okay, so 13, so this group, so the first thing you want to sort by index, you want to sort each subgroup. No, wait, how do you figure this out? So it's, the problem is very simple. Okay, so it's, you simply pick 12 digits. So simple. Pick 12 digits. Wait, it's not that simple. Pick 12 digits, but okay, so it's pick 12 digits such that, let's simplify. Let's say you pick 2 digits, but the maximum, but you must pick two largest number, okay? So if you pick two largest number, so the smaller index come first. Oh God, shit. So the problem, the way we are coding it, the problem is to describe this selection process in a mathematical way. You can do it procedurally, then we can use our recursion algorithm, but we are not doing that. So we are doing this in a declarative way. So the problem is, in essence, specify this problem in a mathematical way, declarative, not procedurally. And there seems to be some difficulty, because if you describe this problem in a procedural way, what you can do is you first pick one number but drop the, you must have room for the rest of numbers, so you must drop 11 digits on the right. Then you pick the one largest digit. Then you do again, but this time you drop whatever is in front of the digit up to that digit. Then you pick another digit, okay? So this way, you repeat this 11 or 12 times, you get the result. You get what you want. Procedural description. But now, okay, this is a procedural description. You want to turn this into a mathematical description. No steps, no order, just like criteria. So the criteria is, to begin with, is still we pick 12 numbers, okay? Let's see, let's turn on my face. So describe this problem mathematically, okay? First of all, we know it's going to, we have a string of numbers. Whatever we do, it's gonna be, we're gonna pick 12 of them, okay? And so which one to pick? There's like hundreds or whatever number of slots. You need to pick 12 of them. So simple. You need to pick 12 of them, and such that they are maximum. So so 12 of them, you pick 12 of them. Can you do combinatorial method? Or can you pick starting from the right? Previously, we picked starting from the left. Can you do this procedurally, but picking number from the right instead? Or what's some other way? So, okay, describe this mathematically. Well, the mathematically is that you just pick 12 numbers, and the result is the largest among all possible 12 numbers. So if you want to implement that way, then you can do brute force. basically means given a list of 100 or whatever number of items, you pick 12 items. You pick all possible 12 items from a list. Then you turn each into a number and you select the largest. So this is brute force. Find all possible selections of 12 numbers of given how many digits are there. Now, given shit. Given shit. What? Wolfram Language tutorial to do. You can, let's see, input, search for text. Okay, so again, so that you got 100 characters, so a list of 100 items, and you take 12 of them. So that would be possible tuples. Okay, so I can, we can start to digress and into another form, but we digress a lot, of course. So, but we can try, just since we are stuck anyway. So tuples will return all possible tuples. So let's say given digits, let's say integer digits, okay? Let's say random, okay? Possible tuples 3, run it. Okay, so you become very large, okay? Yeah, possible tuples. Then you just find the maximum. So if we brute force that way, what would happen? Actually, it's interesting. Because if you have 1200 digits, so let's say length. What you get? Length 512. It's not too big, not too big. So, but here you got 100 digits. Okay, so let's see what copy. Okay, so let's say that, and let's say 12. What's your length? Too many. The length of the output of tuples should be a machine integer. Okay, so you cannot do that. It went beyond machine numbers. So we are doing the brute force way. Yeah. Okay, so the brute force way, interesting. Let's copy the screen. So brute force way is no good. Okay. Then what we doing? So what we doing? Close that, close that, close that, close that, close that. Advent of code. Advent of code. So let's do that. Yeah. So again, a list of items, you want to pick 12 of them and pick the largest number. So let's think about, you got you like shift your pick, you got, you know, a long list, you shift your pick. The best way really is a procedural way. You pick the first number by remove the last 11 items, then you pick the largest. Then starting from there, you pick the rest, then you repeat this 12 times. This is the like the simplest procedural way. Okay, now the mathematical description of this is you just generate all possible 12 tuples, 12 poles. Then find the max, the largest one. Okay. That is actually a mathematical description. The largest of them, of all possible 12 tuples. Okay, but that is, you know, that's impossible to implement. But is there a way to simplify it so we can implement it? Well, yes. If the then we can think about, given the huge list, if the first item is like 1, we can drop it. We can drop. Wait, 12 possible tuples. Okay, that is so there's a combination is huge. So and so but this should be simple. But what is another way, mathematical description for this problem other than just largest of all possible 12 tuples? So again, you got a list, you pick 12 of them and in order, and this should be largest. So let's think about like the physical geometry, something. Like you just shift slots. What determines if one of the items should be picked? Again, we are back to the filter problem. So each element in a list is one of 0 to 9, right? And there's no 0 actually. So we can determine how many, so but we need to, so is there a way to describe this mathematically? Okay, is there a way to describe this? Oh God, mathematically. So just a bunch of numbers. So if you say the largest position like we did before, like we were doing this position largest, that is not helping much because there's so another way is to, oh God, max. So the problem is so simple. You just need to pick 12 items. So Must you proceed procedurally? Well, mathematically, all possible tuples. How do we optimize it? How do we cut corners? All possible 12 tuples. Can we actually cut corners? So, what's another way to describe this problem in a mathematical sense? Is there some kind of number theory? Like, given a number, you want, given a list, you want to pick 12 of them, such that the result digits combined forms the largest. So, but procedurally, you start with picking the first number first. So procedurally, you start picking the first number first and remove the 11 tails. So you have room for the rest of it. So what is this procedure in a mathematical sense? You pick the largest, but you have room. So you just pick the largest 12. So can we actually use this position largest? Position largest, you need to, so if you do this, position largest. Got it. So you got this one there. You see, that's tricky. That one, that index one should not be the end result. That's the number 2. So it should be 4342. So 10. So 12 largest numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you consider first group, is it 12 yet? No. Consider the second group, is it 12? No. Consider the third group, is it 12 yet? No. So given the result of this position largest, you need to truncate some of them. Okay, the question is which. So that's the question. So one way is go through it procedurally. Consider the first group, is the 12 number yet? No. Wait, does this actually work? So consider 1, 2, 3. The fourth group, is the 12 number yet? No. Consider the fifth group, is it 12 numbers? Yes, more than 12. So then you need to drop. So when you drop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So far there is 10 digits. 10, 10 digits. You need to pick 2 more. So why would you pick? So 1 and 4 is 2, 2. So why is 2 not selected? Because it's oh. Okay, that's the 1, 2, 3, 4, 5th largest. That's 2. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. You need 12. So what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So you picked 4, 3, 4, 2, 3. So 4, 3, 4, 2, 3. Then 4, 2, 7, 8. Then 4, 2, 7, 8. So it works out. So this is correct. But how is it compatible with this position largest? Okay. So needs to be 3. One, 2, 3. So it needs to be 3. 3 is here. So position. So is it 12 yet? No. So you need to add and drop some here. Drop some here. Oh, okay. So when it's not enough, you need to drop not in the beginning. You want to truncate. Okay, new insight. When you start to get more than 12 elements, you want to truncate the ones that has huge index. I mean, wait, you want to truncate the ones that has index is low. You don't want the one in the front. Okay, so you want to truncate. So when you take, then when you reach this part, you want to truncate this 1, 4, 3 and take 10 and 13 instead. Something like that. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. 10th and 13th. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 2, 11, 12, 13, 2 and 2, something like that. So 10th and 13th. So wait. That's occurrences of 2. Four and 7. So it is actually taking 4 and 7 there, dropping 1 and dropping 10th and 13th. You see, so this is tricky. It's taking 4 and 7, dropping 1 and dropping 10 and 13. So this indicates this position largest may not work. So we need to go back to the procedural. No, we don't want to do that because we were trying to make this elegant. So you see, this indicates you cannot actually do this. So how do you judge? Why do you, so when this given this, why do you pick 4 and 7? Can that be determined from these numbers here? 2, 3, 2, 3, 2, 3, 5, 6, 8, 9, 11, 12, 14, 15. Oh God, I'm having a headache. I mean, I don't have a headache, but this is, so this indicates that apparently it's taking 4 and 7 because the result is 4, 3, 4, 2, then 3, 4, 2. So 4, 3, 4, 2, 3, 4, 2. So the let's think again. So you just got a list. You just need to pick 12 items. And so it seems to me there's no way to describe this problem in a mathematical way other than the list of all possible 12 tuples, the maximum number, one of them. So you need to do this procedurally. So are we sure that this problem cannot be solved with the position largest? I'm not sure about that yet. Not 100% certain. Position largest. The largest. It may not be able. It looks like it cannot be done with that. Wasted our happiness. So use position largest. Okay, then number, from a number point of view, does this make sense? Like, can this be discussed in a number theory point of view? Like basically you have a function that turns each number to another number. So you are turning this number into another number, into a 12-digit number, which is made up of picking 12 digits. So is there a mathematical relationship between the input number and the output number. So that's another kind of new way to look at. Is it is there a mathematical function? So instead of doing all this picking or possible tuples, if we know a function, we can just turn this number into the result number. Such a beauty. And would that be unique? So another question is, given a number, is that the new number unique? Well, yes, but the return number could come from many of these numbers. Right. As long as, for example, one of the example is one of the result number is a substring in this one of these numbers. So in other words, this is not a one-to-one function. In other words, given a result number, there can come from many of the input numbers. But all these numbers still, is there a relationship? Relationship means, can you specify it in terms of arithmetics? Arithmetics. So now if you think of a number as just a quantity, so 1, 2, 3, 4, 5, 6, 7, they just form a line. So any point in space, they map to a different point. So they map to a different point. So the larger the number does not necessarily map to larger result, of course. So what would the graph look like? I don't know. It would be interesting to plot it. So you specify number in terms of like picking 12 digits of it. That would be, what would the graph look like? So if the whole number is all just single digits, then the result would be very low, like 11111, 12 digits. Now let's simplify. Let's just say we pick 2 digits. So the real number line, the integer numbers, 1 to a billion or trillion. In this number, there's so many digits. They are gigabillion. So many of them become just 11. Some of them becomes 10, but there's no 0. Okay, so 11 or 11 or 12 or 13. Okay, so they all basically mapped into 11 to 99. Interesting. So they all get reduced. They map to 11 to 99. So if you pick 12 digits, they get mapped to, 1111 repeated 12 times to 99999 repeated 12 times. They get mapped into that range. And the mapping fluctuates, of course. Yeah. But can the relationship of input and output be specified in terms of arithmetic relation, like as a elementary function? What we are doing is like picking the numbers apart. But can the process of picking numbers apart be specified in a mathematical way? Well, then we have to think about, okay, picking numbers apart, then each number becomes their nth 10 to the nth power. You think of that in terms of that series, powers of 10 series. So you specify each number in terms of their powers of 10. Then you basically got their each digit. Then you want to pick the maximum digit. That would become to pick the maximum digit. You can't, you see, you can't mathematically describe a single digit, whether it should be picked or not, without consider the whole. That's a thing. That's a main issue. You can't pick a single without considering the whole. So hello everyone. Hello Stefan. Not having a good day. Creeper. We stuck and we went afar. Shit. So let's get back. So this position largest, does it really work? I don't think so. So you just want to pick 12 numbers. So simple. So simple. So can you, instead of the recursion, can you just pick the first 12, then try to move them to the right? Or pick the last 12, then move them to the left. That's another procedural way. You just pick 12 numbers and move them towards the left. Right, you pick 12 numbers, move them towards the left. So, or another way, so this is oh god. So you just pick 12 numbers, then you start to systematically shift each slot towards the left. If there is a slot that's larger than the current number. So that's another way. So So once you move the first digit to the leftmost, then you start to move the second slot to the leftmost to see if there's room. Until there's no room, then you stop. Okay, so this is the second procedural way we discovered, beginning with the rightmost 12 digits. But does this save time, or is this way more efficient, or we don't know? So no, I think our original recursion procedure is the best. So where is it? So day 3 part 2, yeah, our original, like this description is the best. That's the best. That's the most efficient procedural way. Okay, we just need to, we manually code it. That's the most efficient procedural way. Okay, by this method, just repeat it 11 times or 12 times. But now, since we went into this mathematical maximum way, can we still save ourselves? I mean, either we stop that approach, we go back to this elementary. Basically, every programmer is doing this, essentially. Or we continue to think about this, can we somehow get the largest in a mathematical way? You see, this is where I often stuck. Because if I abandon this new way, then I went back to the original, like fundamental, like the most instinctive for programmers way and solve the problem. It doesn't look good because I spent 3 hours, 4 hours, others spent 1 hour, 10 minutes. So, but then if we push for this mathematical way, first of all, we know the generate all possible 12 tuples is impossible. But if somehow we go through this, we use a mathematical kind of description algorithm to solve the problem. If at the end we came out with a solution, then that would be great. We spent 5 hours, 6 hours, but at the end we did it. Most other people haven't done it that way. It's novel. So it's best for me, I think, for my live stream to try to persist with this mathematical way. So right now it's like 4 hours. So let's think again. So just so simple, pick 12 numbers. How difficult can it be? Just pick 12 numbers out of a list. So position largest. Now let's look at Wolfram language. Maybe we see some inspiration. Take largest, give nth largest element of data. Okay, that's what we want. Take largest. That's right. Fucking shit. That's what we should do. Because this guarantees whatever when you say take largest 12, it guarantees to return 12 items. Then you figure out their position. That's it. Jesus. New revelation. Okay. So these are past experiments. Let's now go back to new revelation. Okay. So now let's forget about that. So the huge number. So take largest. Okay. That will do. That will be our something. Okay. Superb. Let's do our supreme programming. Not some bullshit. So take largest. Okay, integer digits at 2 to 3. Okay, so let's say 12. Take largest. Are there 12 of them? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then you say, wait, then what do you do? Take largest. Then you just sort it. Wait, to be sure. Yeah, then you just sort it. Fucking idiot, you idiot. Then you just take the position. Fuck. Then you just, okay, let's do this. X list inc equals to that. Okay, the net. Fantastic. And then you just have then you just run that. What? Okay, so let's fantastic. I think I got it. Okay, so run it. Take larger. Why is it returned twice? You don't need that. Okay, so that is a return value. Then you got then you just sort it. Okay. Okay. Then you just sort that. Okay, so sort. Okay, then this sort okay, then you just part x list. Wait, and you want to take those indexes. Okay, fantastic. I think, and sort it. Wait, we already sorted. Hold on a second. What? Let's try. See. 2, 1, that would be 3, 2. Okay. That would return 3, 2. They need, that would return 3, 2. Yeah. Right. So then you just apply the indexes. Then you combine 3, 3, 4, 4, 4, 4, 2, 2, 2, 2, 3. No, that's incorrect. Because this 2, 3, 4, 2 should return 4, 3, 4, 2, something 7, 8. So what? Take the largest integer digits. Take the largest. Oh wait, take the largest. That's right. These are the largest items. Then you need to take their position. Position from X list. Yeah, okay, this gets a bit tricky, okay. Position and X, so you need map function, okay. Function, what we do is we take the position and the list is from largest. We want to know their position. Okay, that's a list of largest items. We take their position, okay? Do it. Right. Yeah, that looks familiar, you see. So let's see. 1, 2, 3, 4, 5, 6. Wait, largest. Okay, so these are the positions, okay? Then, wait. 8, this is 7, 4, 4, 4, 4, 4, 4, 4, 4. Then 3, 3, 3, 3, 3, 3, 3, 3. Then, wait. What? Take largest. Those are the largest numbers. No, take largest does not work. Because if you have, why take largest does not work? Because if you have a number that's, let's say, 77777777779. Okay, something like let me just show you 666789. Okay, when you have that number, the result should be 666 12 times. Okay, but if you do take largest, that's gonna give you 789 in front, like in front, and there's no way for you to remove them. Shit. So there is interplay between largest and their index, their position. The index must be small, yet it's dependent on which digit are we talking about. So it's like all co-independent from a mathematical point of view. You see, the first number you pick is a number in a list such that it is the largest among the numbers, but such that exclude the last 11 slots. That's how you describe it. Is there any other way? I think none. You see, the first digit among them is really the largest in a given list, but except the last 11 items. So that is really the definition. The definition really depends on the position. You know, it just so except the last 11 items, the maximum except the last 11 item. Is there any other way around it? Because if there's no way around it, then you just cannot describe this in a mathematical way. Oh God. So the first item, so TakeLargest is not working. TakeLargest cannot work. Okay, I think I'm going to stop. TakeLargest. So, but numerical sorts, drop largest, position largest, function repository, position largest. Wait, that's repeated. No, wait, look. So someone wrote this functional repository. So someone wrote this function position largest. Then it became part of Wolfram language built-in function in about 3 years ago, 2022. You see, position largest built-in symbol. You see, however, however, you can see there is this position largest. Let's open a new tab in function repository. So let's look at that. I think this is created by a Wolfram employee, Bob Sanderheinrich or something. German name must be. So position largest, you see, is a function someone wrote, but now it's in Wolfram language. So you see, as a version 13.2, position largest is a built-in symbol. So that is interesting. And we assume this person works at Wolfram Research. This Bob, you need to turn on JavaScript, yeah. I'm pretty sure usually there is a link to the author. How does this take you? Creative Commons, okay. So it was created in 2018 and now it's part of Wolfram Research. I mean Wolfram function. Okay, so I think I'm gonna stop. So what is the condition of the problem now? Well, it's just that I abandoned the procedural, the recursive coding, and opted for the mathematical, but it turns out it's not working. Yeah, but is there any way to salvage it? Take largest by. I don't know. Extract, that's not what we want. Extract by position. Sort, close from digits. Okay, yeah, we know that. Flatten, we know that. Select, we talked about that. Together, that's for fractions. Okay, so I'm gonna stop. So this failed. Well, too bad. Bye, guys. 5 people. Well, I'm gonna stop. What's the meaning or purpose of life? You ask in the wrong time. Bye. I talked about that 2 or 3 videos ago. About religion, like what do you believe in religion? Okay, so stop. Bye, guys. We shut down in 1 minute. Okay, shut down in 1 minute. So this is about won't work because if input is result would be 6, 12, 6. But TakeLargest would include 7, 8, 9 in it. But can it still be solved though? Can you like ignore 7, 8, 9? No. 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 So we can remove that. Yeah. Okay, so that doesn't work. So we can annotate. Can we annotate what we did? Well, this is procedural. So let's annotate, okay? Most intuitive procedural did I spell it correctly? Procedural way. Okay, that's what those are. And then we have, let's see, syntax correct, showing browser. Intuitive procedural way. Then we try to make it into an algorithm, into a function. Then we apply recursion. Okay, so we started to do that. Then we realized there's an issue because this recursion, the first step, you need to truncate the tail of the list by 11 slots. You need to truncate it. That's the first step. But the rest of the step, you need to truncate the head of the list, depending on where you picked your number. So these two are inconsistent. So you cannot have a function that recurs. So you either need to amend, redesign your function. So there's no special step. There's no special first step. Or you do a you do a manual first step, then you use recursion of this function to generate the rest of the digits. The first digit is a manual step. Okay, then we found that this position largest is a functional way, mathematical way. It returns all the largest numbers. So we started on this idea. We thought it's gonna be one simple line, and that's a mistake. Then we spend the next 3-4 hours on this. It's like almost working, but something is wrong. 4 hours spent on that doesn't work. Then I got really pissed. I really want to a mathematical description of this. I start to think about deep analysis. So this problem can be described mathematically. That is, given a number which you turn into a list of digits, given a list, you create all possible 12 tuples of it. Okay, then among them, for each 12 tuple, you combine the digits to form a number. Then you pick the maximum number of all the tuples, all the possible tuples you generated. And we tried that, given a digit, the user input, you have like 100 characters, at least of 100 length. So the possible tuples for, picking 12 out of 100 is beyond machine number. Okay, so that ruled it out. But however, that is a valid mathematical description of the problem. If we have a large computer, in fact, can we do this if we have like enough memory? The length of the output of tuples, okay, so should be a machine integer. Yeah, so the number of such tuples is beyond a machine number. Yeah, so, but can we actually like make this work? I don't know. But anyway, that's a mathematical description of the problem. Then I thought maybe we made a mistake. The TakeLargest will work instead of the PositionLargest. Then obviously no, but so we have an example. So that's where we are. And we didn't finish. It's been somewhat fun. Yeah, so we confirmed my experience that advent of a code has always been kind of not trivial, okay? Not trivial. Bye, guys.